So today we're going to be reviewing Chapter 3, which is going to set us up for linear regression test and confidence intervals that happen in Section 12.2. So if you look at, this is the data I would like for you to enter in L1 and L2. So if you don't have this in front of you, if it hasn't been given to you, pause the video and enter this in L1 and L2. Maybe your teacher can read it to you and you guys can just enter that data. So get that in your calculator now, or pause it. So after that's been entered, we're just going to kind of go through the motions of what we did back in Chapter 3 on how to interpret things and buttons to press on our calculator. So right now I've got everything entered in L1 and L2. I'm going to go to my plots, and it's the very first one is a scatter plot. And the scatter plot, we would like for it to have L1 and L2 set up for that. So I'm going to do a zoom 9, and I've apparently got another plot turned on, so let me turn that off. Okay, and so quick little sketch of this guy. Maybe I'll just do this like up here. So we call, can our waist size predict our body fat percentage? And there's a quick little sketch of that. I'm doing probably a bad job, but you guys get the idea. So generally, as I see, waist size is increasing, body fat percentage is increasing as well, with a moderately strong linear relationship. So after we did this, we were able to find the least squares regression line and make predictions. So let's take a look at that. So I'm going to go to my calculator. I'm going to do stat calc 8, which is linear regression. And right now, you don't have to type this in. You can just press enter, but L1, comma, L2 if you need. Okay, so let's copy down this equation. The predicted, put that over there. So remember, you have to write predicted with the caret. Body fat percentage is equal to negative 62.58 plus 2.22 times waist size. And waist does not have an E. Okay, so there it is. And let's also get the R squared is equal to 0.786. And R is equal to 0.886. So let's do some interpretations from this. Okay, let's first interpret. Let's do the correlation. Correlation. In correlation, everyone always circle 1R so you know it's the 1R. Correlation is R equals 0.886. Strength, form, direction, and story. This is the generally as waist increases, body fat percent increases with a strong positive linear relationship. Strength, form, and direction. Strength, linear, direction is it positive or negative. And talk about the story. So that's the generally statement. Okay, some other things. So interpret correlation. Also remember, correlation is a number that is at largest 1 is at smallest negative 1. Remember, if it's a strong negative relationship, it would be negative. Strong positive would be 1. You would never have a correlation above or below 1. 0 means there's no linear relationship. Okay, so that's correlation. Let's interpret the slope. So the slope is the number next to the x. So that's 2.22. And if you remember, slope, do this in a pencil, was my cloud method. So you put it over 1, and you say, on average, as waist increases 1 inch, body fat percentage will also increase by 2.22%. Okay, so that's my cloud method. You start here with waist, you put your fraction, put it over 1. As the waist increases by 1, body fat percentage increases, because that's positive, by 2.22. There's my cloud method. Okay, now, leading us to, let's go to our y-intercept. And our y-intercept is the negative 62.58. It's the number by itself. A plus bx, it's always the a. This one, when a y-intercept occurs when x is equal to 0. So if you actually plug in 0 for waist size, you're actually making a prediction. Our model predicts that a person with 0 inches waist, with a 0-inch waist, will have a negative 62.58 percent body fat. Okay, and clearly that's nonsense, and sometimes they'll ask you, does this apply to the real world? And no, it doesn't. You're extrapolating, your data's way up here, where someone with a 0-inch waist is like way down here, and so it would make sense that you would have a negative number. So those are the three main one. Oh, let's do the r squared. So r squared, and this is the one that's called, this is the coefficient of determination. And they might even call it correlation. I've seen correlation be called correlation coefficient. It's still just what r is. So coefficient of determination, we start this one, we turn that into a percent. We say, forget how I start this one, 78.6%. Oh no, that's it. The least squares regression line. Least squares regression line predicts about 78.6% of the variation in body fat percentage. You're predicting body fat percentage. Okay, so that's how I start one. That I changed that throughout the years, so that's why I was kind of have to think about what I'm writing for that one. Okay, and the last one, which you're never going to get from the calculator, they'll have to give you in a computer printout, and that's the S. I'm just going to throw that down here. I couldn't ask you that in this problem, but S is the standard deviation of the residuals. And the standard deviation of the residuals is the average error when using the least squares regression line for prediction is blank, whatever that number is, and you always use the y, it would be the y variable, which is blank percent. So those are the big ones from chapter 3 that you guys are responsible for, and I could very well ask you to do this stuff again. Now, another question that I could ask you is a linear model appropriate? And to answer that question, you have to take a look at a residual plot. So you're going to plot L1, which is waste, against residuals. So residuals get calculated every time you press stat calc 8. So they've already been calculated. So let's go here and second, go create a residual plot. And the way that's going to look is you'll have L1 versus residuals. So go grab the residual list under the list menu, or under stat, second list. Go all the way down and grab the residual. And do a zoom 9. Okay, so there it is. And you would just give me a quick little sketch. Don't forget to label your graphs. And we would say, since the residual plot shows scatter and no pattern, a linear model is appropriate. Okay, so we're looking out for those parabolas, and that's not showing up in the residual plot. So to answer that question, since the residual plot shows scatter and no pattern, a linear model is appropriate. Getting a little sloppy here. So that pretty much sums up all of chapter 3. There you have it. And we're going to come in with chapter 12, and we're going to look at, let's do this. While I have it. So this is a computer printout. I'll stop there. I'll show you the computer printout later on. Okay, guys, I'll start this up again on a new video. Bye.